Hi everyone, welcome back. I hope you're enjoying the series so far and you're gradually becoming a better network troubleshooter. In this tutorial, I'll show you how to view routing tables using the route command. So, routing tables are a very important part of the Windows TCP/IP stack, but like we have seen in the case of Nestat, this is not something that the system gladly shows to the casual user. So, as you may remember from running the ipconfig command earlier in our tutorial series, we have seen how the TCP/IP stack works on our machine. Either ipconfig on Windows or ifconfig on Unix offer a much more reliable and compact information that any property sheet of any adapter, as they show specifics of how your system has actually configured the protocol suite. And regardless of the number of network cards you have, by running ipconfig you have detailed information about each of them in a very easy to read manner. And usually when problems arise, the best place to start is to compare the information given by ipconfig and the information you have in your routing tables. And to see the routing tables, you can use the route command in command prompt, and usually it's used with the print keyword. Right, so let me look for command prompt. Right, CMD. Right, so we can use it like this. And this keyword is the one that really outputs the routing table of my machine. If you run the command by itself, it will print only the help section of route, which is also useful to read if you want to read more about the command. Right, so let me run this command. Alright, and as you can see, it shows our routing tables. Right, so the first heading up here is the interface list, which displays all your current network interfaces, and you can also see this type of information when running the ipconfig command. But in order to understand the output given here below, let me just talk about the workings of a router. So a router receives and forwards traffic from a network to another, and as such we have multiple network cards, or I should better say network interface cards, each corresponding to a different interface or network segment. So when you send data to a destination located in a different network segment, or to be much clearer, different than the network segment you're presently in, that data as a flow of packets is sent to the router. And there, the router decides to which network interface it should forward this data, and it will involve the routing table in its decision-making process. Right, so now if you look at the output of the route print command, you will see that the routing table is divided into 5 columns, at least for the IPv4 routing table. Right, so the first column is the network destination column, and this column lists all of the network segments that the router is attached to. Then you have net mask, and this column provides the subnet mask, not of the network interface that's attached to the segment, but of the segment itself. Right, so pay very close attention to that. This virtually allows the router to determine the address class for the destination network. Then you have the third column, and this is the gateway column. And once the router has determined which destination network it needs to send the packet to, it looks at the gateway listing. And the gateway listing tells the router which IP address the packet should be forwarded through in order to reach the destination network. Right, so whenever you see here on link, rest assured that they are addresses that can be resolved locally, and they don't need a gateway because they don't need to be routed. Then you have interface, and this column tells the router which network interface is connected to the appropriate destination network. So virtually the interface column only tells the router the IP address that has been assigned to the interface that connects the router to the destination network, right? Then you have the final column, and this is the metric. And this metric column is very interesting because it specifies the cost to reach a destination. And as you can see here, we have a 10 and a 266 for the next ones. And routes with lower metrics have priority over routes with higher metrics, and that should be like a general law, like the law of gravity. Typically this metric is based on information such as the length of the network path, the bandwidth, hop count, and so on. If you want to read more about it, go ahead, but I won't insist on that. Then as you can see here, we have no persistent routes, and these are routes that are added by the network administrator explicitly. Right, so afterwards we have the IPv6 routing table, and this respects the same policy. You have the interface here, then the metric, network destination, and gateway. And let me talk about IPv6 addresses. So you have different types. You have global addresses, and these are just like public IPv4 addresses, and they are usually globally reachable on the IPv6 architecture of the internet, and they typically begin with a 2 or a 3. And in this case here, interface 5 has a network destination that has a global address. Then we have link local, and I believe these are similar to automatic private IP addresses in IPv4, and these are actually used on a specific link, and you normally see them with the prefix FE80, as you can see them here, and these are local IP addresses. Right, you also have site local, and these are like private IPv4 addresses. They are used, or should I say, or I should add also reused within an organization's intranet or for different sites of that organization. And virtually you can identify these by their prefix. They always begin with FEC, FED, FEE, I believe even FEF. But as far as I know, these have been deprecated, but can still be used in current IPv6 implementations. Last but not least, you also have multicast addresses, and you use these when you want to send data to multiple destinations, and they can be easily identified by their prefix starting with FF00, as seen here. Right, so that's it for today. That's how the route print command works. I hope you have enjoyed this tutorial. Don't forget to subscribe, and I will see you later.